Okay. And for that recording, okay. So what we're saying is, let's say once you log into the computer, you log in as a regular user. As you can see, it has a $sign, right? So I have a choice. I can become root permanently, at least for this session. Okay, as you can see, I have a $sign here, or I can do my continuous work. I can do using sudo, like for example, sudo yum-y update. Okay, if I try to do this, or let's say I want to install a software, yum-y install, let's say for example, OpenLDAP. Okay, see, it says when I type the command, it says you need to be root to perform this command. So if I don't want to become root, all I have to do is just type sudo and then the command itself. Okay. See, now the system will not complain. It says that you have OpenLDAP is already installed. Say for example, I would like to install a software called Named. Okay, let's see. Let's say I'd like to install a software called GCC. Let's try this one. Okay, see, it is installing bunch of softwares, right? It is installing a something called GNU C compiler. We'll take a look at it once we go installing softwares manually. Okay, let it finish. Okay, so still we are root, right? Sorry, regular user. Let's say I'd like to create a user account. Let's say user add JDOE, let's say number 1. Okay, see, the system said permission denied. Let's try the same command using the sudo. Okay, now it gives a privilege. See, now the system didn't complain. So again, it's your choice either to become root all along or just use the sudo command every time you want to do something as a root user. Okay, so let's say if I want to become a root, I can do sudo -i. Okay, pwd okay, sudo -i, and let's try another one, sudo su dash. Okay, now if I do pwd and if I do, let's say, echo $path, okay, here is a little difference. As you can see here, when we type sudo -i, okay, the system does puts the cursor or the user in the root's home directory, right? The path of the user is this, right? Same thing, almost same thing here, except user local sbin, user local bin, except it does put this path in the user. Otherwise, nothing else. But there is a huge difference. Say, for example, if I type sudo su without a dash, then you will see the difference. Okay. See, before when we did sudo su dash, let's take a look, closer look. right? When we do sudo su dash, it became root, right? And this tilde sign says that you are on the user's home directory. This tilde sign is located right above your tab key or right below your escape key. Okay, that tilde means that's your home directory. Okay, when we did sudo su without a dash, then the user doesn't go to the user's home directory. The user is root, still it is root right here, right? As it is here, but user is not in the root's home directory. That's a difference. Okay, if we do pwd, see, before pwd was /root. Now the pwd stands for present working directory. Okay, where we are right now. Okay, there is a pwd, there is also a called cwd. Cwd is current working directory and pwd is present working directory. Either way, the both of them are the same thing. Okay, so that's the only difference. Now let's say we created a user account called jdo. Where do we see the user accounts? In this file, right? etc password, remember etc password, etc shadow, and etc group. Okay, when you create a user account, the system assign him a number. Okay, it's called uid, right? So now let's assign a password to this user. So if we say password jdoe1, she will get permission denied. Why? Because it says only root can specify a username. So if we do sudo password jdoe1, now the system will not complain. Why? Because we added the extra power, which is do whatever the root can do. That's exactly what does it mean. Sudo means do what the super user can do. Who is the super user? Super user is the root. Okay, now let's say we assign him. See, the system complains that the password is too short, but eventually it takes it. Okay, now let's say we would like to give this user the root privilege. Okay, so how do we do that? We can do sudo vi sudo. Okay, vi sudo edits a file called sudoers. Okay, now let's say we come to this line and we put this username. Okay, what does this all means? We'll talk about this later. Okay, now let's save it. Let's become the user. Su-jdoe1. This is how you transfer between one user to the other. Okay, that dash specifies. If we don't specify the username, that means we are going to become root. Okay, but if we specify the username, okay, that means we are trying to become that user. Which user? Whatever username we specified after the dash. Okay, so it asks for password. Okay, see, we become user jdo. Now let's say we want to become root. Okay, as this user, so we type sudo su dash. It says we trust you have received. This message comes in. Okay, if you want to read, just read it. So let's say if I type the wrong password, let's see what happened. Okay, see, it says 3 incorrect password attempts. Okay, meaning you cannot be there because you didn't type the password. Now let's try it again. This time we type the correct password and we become root. See, it says root right here and we have a pound sign. Now let's try another one. Let's create a user account called user add JDOE2 and let's assign him a password. Okay, now let's become that user. Okay, see, as a root, when we become root has the highest privilege, right? As a root, when we try to go to a lower privilege user, the system never asks for password. See, when we type this, the system said, okay, you are already a super user and you want to become a lower privilege regular user, why not? You don't need password. Okay, so now let's say if we type, let's become root. Okay, so let's say we type the password, the correct password. The system said that your name is not on that file and this incident will be reported. If the sudoers file is configured to report the abuse, okay, then that user will be reported. Where is that file located? That file is in etc directory and here is the file cat. Okay, see, it says you cannot view this file because you don't have the permission. Who can view this file? Let's see. I'm in the browser, that's why it. Okay, see, it has the root has the right to read only, and root's group, which is also root, has the right to read only. That's why you cannot open this file. So if we type sudo cat, okay, okay, now it's correct and it is asking for the password. Oh, okay, I see. That's because that user is not there. Now, where is that file located, we said? In the etc directory. What is the file name? Sudoers. Okay, remember we added the JDO user one. You will see it is on this file. Where is it? Right here. Okay, so let's say if we use the vi sudo command, okay, it does the same thing. It does vi for us automatically on that file. So it's an alias. So let's say if we do alias, what is an alias? Alias in Bengali can be called as what is it? Orphe, right? Alias command is not found. Okay. Alias is, say, for example, somebody's name is, let's say, Muhammad Noshin. He can be known also as, let's say, Joshim, for example. Okay. Basically a nickname. Okay. In systems, we do create a lot of aliases, and as we progress, as we move forward, we'll see how we can create aliases or we can delete. There are some aliases already created, like for example, anytime you do a CP is actually CP-I. What is CP-I? For example, let's say I have a file. Let me go to my home directory. Let's say I have a file called let's say I created a file called file1. Okay. So I do CP file1 file2. Okay, see, the system doesn't complain. Why? Because file2 doesn't exist, so it just basically creates a file. Now if I want to do it again, now if I want to do it again, CP file1 to file2, see, the system will say, you sure you want to overwrite? Okay, why? That's because of this. CP is set to an alias. I is for interactive. If we say yes, then it will be copied. If we say no, then it will not be copied. Okay. Today we'll see also another thing. Like for example, let's say if we go to user, okay, user bin is a directory. See, user bin is a directory. That's where most of the executable commands are there. Like for example, if we say which, we are familiar with this command, which ls, okay, the system will say that it is located in user bin. Okay, and the alias is set to color equal to a row, meaning if it is a directory, show one color. If it is a file, show another color. So let's say for example, if we say alias ls equal to, let's say we just say ls, for example. So what will happen now is you will see everything black and white. Why? Because, oh, come on. Give me 1 second, please. Okay. Okay. So if we do which ls, as you can see, alias for ls is only ls, no color. So if we go back to what it used to be, let's say if we set this up again, okay, and if we type ls now you see the color again. Why? Because it is instructed, if it is a directory, show one color. If it is a file, show another color. If it is a linked file, then show a different color. Okay, so this is how we set alias. You can set alias for almost anything. Okay, but don't do any dangerous stuff. Like for example, let's say ALI okay, so reboot command is located on user bin, user s bin, right? Say for example, we set alias reboot equal to, say for example, we call it RB, just for example. Okay, now if we type RB, Let's see what happened. Why it didn't work? Oh, okay. No, this has to be set in another place. Anyway, we'll talk about this one later. So alias, okay, alias is, and we can set any command for such as this one. We set it as the root commands we saw didn't work, like for example RB. Okay, it has to be set in a different place. Okay, we'll talk about that later. Now, one thing we need to do here is, if we want to see what is a file, what is a directory, we can do ls-ltr. Okay, so if it is a directory, remember we said if it is a directory, then you will see a D. Let's see if there is a directory in here. No. Okay, looks like this place doesn't have any directories, but if we want to see a directory, let's say ls-ltr, for example, etc. Okay, you will see there is a, like for example, this one is a directory. It has a different color, right? This is a regular file. It has a different color. If it is executable, you will see another color. Some of them you might see like this. Okay, these are called linked file. So let's go back to, and linked file starts with an L right here, file or directory. Okay, so there are two kinds of links. One is called a soft link and one is called a hard link. Okay, so let's say now, let's say we create an executable. For example, vi, we call it, let's say script 1. Okay, let's go back to our home directory. That will be better. So as a root, we are on our home directory. Let's say we create a file called script1.sh. No, let's keep it that way. So let's say in this script, we'll create a file, we'll put ls date uname -a. Let's say ls-ltr. Okay, so this script, when it is executed, it will run 4 commands. Okay, ls-ltr. Remember, we have to make it executable. See, it says the permission denied. Why? Because it is not executable. Or there is a command called source. If we type source, that means we are not making it executable, but would like to see how the script runs. Okay, so if we type source script 1, see, it will work. So we put ls, then, so this is the ls, right? We put date, we put uname -a, and then we did ls-altr, right? That's why basically it shows everything. Now, let's say we want to create an alias for this file. So the alias will be, how do we create that? ln-s root script 1 user bin script 1. Okay, so let's see what happened. Okay, nothing happens here. Let's see ls-altr user bin. Let's do user bin. Okay, you see the script 1 here? It says that script 1 you can found it in user bin, but actually it came from this location, right? See, script 1 is located right here. Where it is? In the root home directory, and the file name is called script 1, and this is the linked file where we are looking this. If we go to user bin, let's do ls-ltr. Okay, see at the very bottom the script 1 file. Okay, now let's see, if we go back to our where we created it, if we do du-sh script 1 to see the size, see it says it's 4K, right? Now let's say, okay, let's do a cat. We see there are 4 commands in here, right? If we do a cat on user bin script 1, okay, we see the same thing. So basically it's a file that is linked from the original location to the destination location, but no content has changed. So now let's say if we change something over here, we are in, so if we change some content here, let's say we put id who am I, who dash r. Okay, let's say we added 4 more things. Okay, again we are on our original location and we type script 1. Okay, see the 4 things we added in the original location. Let's see on the destination location. The destination location was user bin script 1. Okay, see, whatever we changed on the original location, it did changed on the destination. Okay, that is called the original command we used to create this link is called soft link. Let's see, this is the command we use to create the link. Now let's create a hard link. So let's create a file called, let's say, script 2. So cp 1 to, let's say, RIPT 2. Okay, now let's create a hard link. Root script 2 user bin 2. Okay, in original location we see a file called script 2. Let's see the destination location. user bin, we can do script and star, so it will show both files. Okay, see, on the user, on the script one, it shows this way. It says basically that this file originally came from this location. For script 2, we didn't use the -s, right? Or remember, on script 1, as you can see this command, we use the s. It's called soft link, or you can call it symbolic link. Okay, when we did the script 2, when we linked it, okay, it didn't create a symbolic link. Also remember, when we changed script 1, right, it changed on its original location, it also changed its destination location. Now let's see for script 2. We are still in our original location, which is root and script 2. So let's vi. Okay, let's add few more things. Let's say we'll add uname. Let's say du-sh. Basically, some of the commands we are just typing, you know. Let's say df-h, and let's say echo now. Let's say if we don't want to make it executable, if we say source script 2, it will execute all the commands. If eventually it was echo hi, the system says hi. Now let's see the destination. The destination, remember, was user. Okay, the source, see, we put ls all the way up to echo hi, right? Now on the destination where we created the link, see, on the destination also it changed whatever we put in the original location. So what is the difference? Okay, what is the difference between symbolic link and what is the difference between the hard link? Looks like both of them are working the same way, right? Now, as you can see here, every file ls-i, okay, when we type that, it shows a number. Okay, this number is called inode, and this is how the system locates anytime, let's say we type which, let's say for example script 1. Okay, the system said, I don't know where it is located. Why? Because its script 1 is not registered with its internal database. Okay, the system creates, anytime you create a file, the system looks at this path, even though it is in there, even though it is in user bin, but originally it is not located in user bin. Originally it is located in root and then the file name, the script 1, right? So the system looks at a number. That number is called inode or index node. Okay, so let's say if we see script 1 has 835482, the inode number. Let's take a look at the inode number on user bin. Okay, See, it has a different inode number. The original one was 835.40482. This one is 935.1502, right? Let's take a look at the inode number for script 2. It is 835.480. If we look at okay, see 835.480 on the original location, and on the destination location also it uses the same ID. So basically hard link is not two different files. Hard link is one file located in two different places. Soft link is two different files located in two different locations. Okay, do you really need this? Well, as I said at the beginning of the class, you don't have to memorize anything, but you have to understand these things. Like what is, let's say if you go for an interview, if somebody asks you, what is a soft link? And if you feel like that I never heard of it in my life, then it's a different story, right? But at least you know what is a soft link. In user bean, there are a lot of soft links. See, there are a lot of soft links in here. It will be coming very soon. See right here. See, this command is not located in this place. This command is located in this one, user SBIN. Okay, LD is located in this location. Vim is located in this location. Okay, it doesn't have to cross the directories. It could be located on the same location. Why do people use symbolic links? Let's say original name is very, very long, okay, and they want to make it very short. Like for example, let's say we create a file called, let's say this is my first command I want to execute. Okay, let's say we give it a very long name, and on that file, let's say we put some commands, like for example ls date, who am I, echo, let's say this is a test. Okay, now we created this file. Okay, that's a very long name, very hard to type. So let's say we copy it and we execute it. This is a command. It did what it's supposed to do. Now let's say for somebody it's very hard to type. So all we have to do is ln-s, type this file name, and let's say we call it cmd1, for example, command 1. Okay, see, we created the symbolic link. Symbolic link always shows up in a different color, and it says the cmd1 is actually originally this one. So now if we type source cmd1, okay, see, it does the same thing. So that's why people use symbolic link. The original name could be very long. Sometimes it could be like the word has upper letter, lower letter, different classes. Okay, that's why people use a symbolic link. Okay, symbolic link or hard link. Okay, Now, let's take a break for about 10 minutes to do our Asr prayer. Starting next class, please pray the Asr before you join the class. Okay, so let's come back at 7:05. All right. Okay, so we're back. So we learned what is symbolic link. Last week also, not last week, the previous week also we talked about processes. Okay, processes are programs that runs on a computer to give you a optimal environment. So the computer runs and you can do your work. Okay. Any question? Without the process, there is no operating system. Without the process, there is no operating environment. Like remember we talked about how the computer starts. Okay. See the first process. So when the computer boots, right? We're talking about computer startup. System boot up. Okay. Okay. Now, so when a system boots, what happens is the system boot up. First, let's say you press the power button. That happens on any type of computer. When you hit the power button, first thing it does is it goes on a check. It's called post. Power on self test. Okay, there is post for power on self test. So at that time you'll hear the computer is making much more noise than usual. It turns on all the fans with the highest power, whatever power it has. The bigger the computer, the more noise it will make. Let's say for example, if you start, for example, one of these computer, let's say, yes. Oh, let's say, okay, or V880, for example, V890. If you turn on one of these computer at one point, see now it is selling for 550. I remember this computer used to be about $500,000 because at that time the computers were not that powerful. So whatever was there at that time, that was probably about 30 years ago. It was about $500,000, and at least 4 or 5 people needed to lift that thing. Okay, nowadays the same powerful computer, you can put it on your palm. Okay, that's how the computer hardware improved. Anyway, once you turn on, right here is the power button, right here. You see the power button right there? Okay, there is the key to lock it, and this is the power button. Once you turn on the power button, basically it has about, I think in the front, it has 8 fans. On the back, it has another 8 fans. This thing generates gigantic amount of heat. Okay. And when it turned on, you could hear the noise at least 50 feet away. Okay. That's how much noise it used to make, especially when you turn it on. Even nowadays, when you turn on a computer, you will hear little bigger noise. Okay, why? Because it goes to test all the equipment on it. Like for example, motherboard, RAM, hard drive, fans, RAM, connected devices such as keyboard, mouse, monitor. It checks basically everything. Okay, immediately after that, it goes to a process called init, okay, or initialization, and it creates the first process. It's called process ID or PID number 1. Okay, once it creates, actually before it creates the PID number 1, it goes to check it's something called kernel. Okay, what is kernel? Basically, kernel is the brain of your operating system. Okay, now the hardware test is done. Now the software test begins, because once the computer runs, it runs on hardware, but everything is software by then. Like for example, your mouse will work because the software driver permits it to work. It works with the operating system, even though it's a hardware, but without the help of a software it cannot function. Okay, so it initializes something called kernel. Once the kernel is initialized, by that time the process PID 1 is started, and then the system goes to a file called okay, it is in etc directory. The file called group.conf, grub, where is it? Oh, okay, it's right here. So the system goes and open this file. Okay, that's a very complicated file. Okay, basically it says what to do when it boots. Okay, it goes to a line, usually the latest kernel. Okay, see, this is the kernel version number 509. This is the kernel version number 517, 118, 517. So basically it goes to this one where it says Linux. See, Linux, not menu entry, Linux. It goes to this line and it sees what to do, how to boot. And once it boots, what is the final destination? What is the user level interaction? Okay, so it says operating system is Linux, and this is the boot image. Okay, the root file system is located in this something called UUID. We will learn it later. Okay, and during the boot up time, it will stay read only. That's what RO stands for. Then it says if it is a console, then give the first console as TTY0. Okay, as you can see here, console equal to TTY0 and TTYS0. Okay, then there are some other information. We'll see. Let's say, for example, we lost the root password. How do we recover the root password? At that time, we have to come to this line, edit this line, and make the system go to something called single user mode. So the system has multiple modes. Like for example, let's say if we do who-r, the system says run level 5. Okay, so what is run level 5? Okay, Nowadays, this file is not used anymore, but before it was. So basically the system runs in two modes. One is called run level 5, and one is called run level 3. Now actually it has multiple modes. Let's start from the beginning. Run level 5, run level 0 is when the system is powered down. It's not running. Run level 1 is called single user mode. We'll see how to go to the single user mode. Okay. Run level 2 doesn't exist. Run level 3, the system does exist in a multi-user target mode, which is basically no GUI available. Okay. Run level 5, the system runs with a limited number of GUI. GUI means graphical user interface. In a production environment, in your lifetime, you will never see a system is running on run level 5. You will always see it is running on run level 3. Run level 3 and 5 is the same thing, but on run level 5, it has graphical user interface availability. Run level 3 doesn't have any graphical user availability. Linux is not Windows. When you work on Linux, you don't use keyboard, mouse, and keyboard to work on the system. Yes, keyboard you use to type the command, but your system is not connected to the keyboard. You use the SSH to go to the remote system. On Windows, you can have a keyboard and mouse connected. Okay. So that's why about 99% of the time you will see when you do who-r, your system will say it is on run level 3. Okay, so run level 3 is full mode with no GUI. Run level 5 is multi-user mode with GUI, and run level 6 is reboot. Like for example, if we type init 6, see the system is going to reboot. Okay, if you type init 5, nothing will happen. If you type init s, the system will go to single user mode. Let's see, let's go back to our EC2 instances. You will see the system is rebooting. Okay, it came up already. Yeah, see, it is down. That's why it didn't connect. It says running though. Okay, so it came up, and if we do uptime, we'll see the system just rebooted. That's why it says 0 minute. Okay. So far, any question? So basically, we learned only new thing we learn is soft link and hard link. Okay, and we talked a little bit about how the system boots. So we came up to here. Okay, next we'll learn how to boot the machine in a single user mode, boot up process, reset the root password, system run levels we just talked about. Run level 0 is the system is powered down. Run level 1 or run level S is the single user mode. Run level 2 doesn't exist. Run level 3 is multi-user mode without GUI. Run level 4 doesn't exist. Run level 5 is multi-user mode with GUI, and run level 6 is reboot. So how do you go one run level to another? You just basically say init. Like for example, if we say sudo init, let's say for example 1. Okay, it says the system is going to rescue mode now. Okay, which is basically the single user mode. The console, it's better to see, we'll see on a different platform, not in AWS. Okay, run level 1, basically the user should not be able to connect. Let's see what happened. Because run level 1 is not a multi-user mode. Run level 1 is only for when the system is, see, it is in single user mode. It is not even connected here. Okay, so basically with AWS, I don't think I can show you the single user mode. Let's reboot, then it should be fine. Okay, let it come back. Okay, single user mode, I'll show you in different platform. Like for example, on on virtual machine or something else. Okay, so we'll actually stop here. I still have some I'm still under the weather, not COVID, but I still have runny nose and fever and stuff. That's why I canceled the class on Monday. So whatever we covered today, I'll send you the recording, and inshallah we'll resume the full class on Monday. Okay, any question? And also today our presence is very low, so I'm hoping everybody will join next Monday. Any question?